Welcome back to the deep dive. Our mission, as always, is pretty straightforward. Take complex stuff, unpack it, and give you that deep understanding, fast.
And today, we're tackling something, well, something quite heavy.
Yeah, it's a journey into how our brains handle really tough ethical choices, emotional stuff, and that feeling of being torn inside. We're talking about moral injury.
Mm. And it's important to get this right. Moral injury isn't just feeling stressed or guilty. It's much deeper.
Right.
It's that profound sense of fracture, that hurt that shakes your identity when you're involved in it, or you see things that just violate your deepest values. Or maybe when you feel let down by people you trusted, like leaders.
A real internal conflict, then, ripping at how you see yourself ethically.
Exactly. It's intense.
Okay, that is heavy. So to help us navigate this tricky neuroscientific territory, our sources give us a really neat framework instead of just throwing brain terms at you.
Which can get confusing fast.
Totally. We're going to use an analogy. Think of it like a team, like a group of friends, maybe like in Pretty Little Liars, but they're brain parts on a Lego adventure. High stakes.
Yeah, it's a way to bridge the gap.
Yeah.
We want to explain these key brain areas, like the anterior cingulate cortex, the orbitofrontal cortex. So
Yeah.
maybe a 5-year-old gets the gist with the Lego idea.
But we also need the depth, right? For the parents, the adults listening who want that clinical, technical side, especially in this omics era we keep hearing about.
Exactly. Dual audience, simple analogy,
Uh-huh.
but with the serious science backing it up.
And the core of this whole deep dive is figuring out how this brain team, this network, works together when things get really ethically tough. The moment moral injury hits. And the star player here, the one pulling together feelings and choices, seems to be the anterior singular cortex. We're calling it the group planner.
The Lego planner, yeah.
The big question is, how does this planner work with everyone else when that offer thought hits? Did I mess up? Did someone I trust just stab me in the back?
So first off, decision-making, especially the tough kind, isn't a solo act in the brain. It's fundamentally communal, a group effort.
Right. Not just one spot lighting up.
No, definitely not. When you face a sudden ethical crisis or, a big emotional shock, this whole circuit of specialized areas kicks into gear. Each part brings its own expertise to try and reach a balanced and ethical decision.
So it's more than just a collection of parts. They have to work together, like a cohort.
Precisely. A functional cohort. They really only do their best work as a team. So let's start with the leader, the coordinator.
Okay.
That would be the anterior cingulate cortex, the ACC.
Our Lego planner.
The planner, got it.
On the surface, using the analogy, the ACC helps the Lego friends talk about their feelings and figure out choices, especially when things are tricky or confusing.
Making sure no one gets ignored when they're upset or scared. Sort of the group's heart.
Kind of, yeah. But, for the adults listening, the ACC's job is much more sophisticated than just feelings.
Okay, let's get into that. What's the technical side? It's really famous in neuroscience for conflict monitoring and error detection.
Conflict monitoring, like noticing when things don't add up.
Exactly. It's constantly checking.
Yeah.
Did things go as planned? Or is something unexpected happen? If there's a mismatch, like a big one, the ACC basically sounds an alarm.
An internal alarm bell.
Right. And its location is key. It sits right between the higher level planning areas in the front of the brain, the prefrontal cortex, and the deeper, more emotional limbic structures.
So it connects thinking and feeling.
Perfectly put.
Oh.
When it detects that conflict, maybe a choice feels ethically wrong, even if the outcome looks okay, or maybe you did the right thing but got betrayed anyway.
Ouch.
Yeah. It signals, hey, we need more control here, rethink this. It pulls together signals about pain and reward. That's why moral pain, like in moral injury, feels so physically awful. The ACC treats it almost like a physical wound.
Wow. So it demands attention. It forces the group, the cohort, to replan.
Immediately. It needs recalibration now.
And often that need for immediate recalibration comes from something...
Sudden.
Right, something shocking. Which brings us to the next team member.
Yes, the instant reaction specialist. We need to talk about the supramammillary nucleus and its connection to the startle effect.
Supramammillary nucleus. Okay, that's a new one for many, I bet.
It often gets overlooked, yeah.
Yeah.
But think of it as the surprise sensor. It's the part that notices those sudden, unexpected things, a loud noise, something flashing in your vision, the classic jump scare.
And it does more than just make you jump, obviously. How does the startle feed into the ACC's planning?
Critically, it changes everything almost instantly. And this is where You really need to get technical for a second. To understand how the ACC plans under pressure, we have to see it through the lens of biconditional associations tied specifically to that startle effect from the supramammillary nucleus.
Okay, hold on. Biconditional associations, let's break that down. That sounds like A happens if, and only if, B happens. Is that right?
That's exactly it. Very good. So in this context, A is the ACC kicking into its emergency planning mode.
Okay.
And B is that immediate, almost unconscious jolt, that startle reaction from the supramammillary nucleus.
The shock itself is the trigger that forces the planning to change.
Yes. The shock is the condition. It fundamentally, instantaneously changes the strategy. Think about witnessing something traumatic, a sudden moral crisis. Your brain doesn't have time for a long, thoughtful debate.
No, it needs to react.
Right. The shock has to be integrated now. And the supramammillary nucleus is vital here because it quickly fires up parts of the hippocampus, the memory center, linking that emotional shock to where and when it happened. It uses this specific brain rhythm, the theta rhythm, to make that shocking event incredibly memorable.
So it's not just fear. The shock forces the ACC, the planner, to tag that event as high-priority trauma and changes how the brain records it for the future.
Absolutely. It basically makes the emotional input non-negotiable in our ethical thinking. If the planner, the ACC, somehow ignored that shock input, well, the resulting decision would be missing crucial context. It wouldn't make sense.
That sounds incredibly fast.
Yeah.
Moving from surprise to a whole new plan in, what, milliseconds?
Pretty much, yeah.
How does the team keep up? How do the planner and the sensor, which are in different brain areas, talk so quickly and reliably?
You need a super fast messenger, a dedicated communication line. And in this specific functional group dealing with moral stress, our sources point to something called the hemifusum, our connection expert.
Hemifusum. Okay, another one that's not exactly a household name.
No, you won't find it highlighted in many basic anatomy charts. But think of it as more than just a regular brain pathway, like the standard white matter tracks.
How is it different?
Its speed and its specificity, it's like having a dedicated fiber optic cable instead of a general highway. It might even use signaling that doesn't rely on the usual gaps between neurons, the synapses, allowing for incredibly rapid transmission.
Secret messages, like the Lego analogy said.
It's exactly. Delivering urgent news between the deeper emotional bits and the higher planning areas. When moral injury hits and the whole system feels overwhelmed, the hemifusum is crucial for making sure the team stays coordinated. It prevents a total communication meltdown right when stress is peaking.
Keeping the group coherent in that initial chaos?
That's its job, maintaining coherence.
Okay, so we have the ACC planning reacting to the surprise signal from the supramammillary nucleus and the hemifusum ensuring they're talking instantly. But, good decisions, especially moral ones, need context, right? You can't just react to the shock. You need history.
Absolutely vital. And that brings in the AVTC, the anterior ventral temporal cortex, our memory matcher.
That's AVTC,
Yeah.
memory matcher. Okay, so this part's about recognition.
Yes, recognizing faces, places, objects, but crucially, recognizing the emotional feel of a situation.
Ah, okay. So if this current moral mess feels like something that happened before, like maybe you felt betrayed in a similar way years ago, the AVTC brings that memory forward.
Precisely. It integrates memory with what you're seeing and feeling right now. The AVTC gives that essential context. It helps the team learn, basically, what worked last time and what failed. It tags the current situation with emotional meaning based on past experiences.
Like seeing injustice. The AVTC recognizes the scene, the people, but also that feeling of unfairness.
Exactly. And that feeling directly informs the ACC's planning. Without the AVTC, every ethical challenge would feel brand new. You'd just keep making the same mistakes.
Okay, so memory feeds the plan. But a plan is useless unless you act on it. When the ACC figures out a constructive way forward, maybe apologize, maybe step back from something harmful, how does that translate into action?
Right, we need the action department. That's the basal ganglia, or BG, the movement manager.
Basal ganglia, I've heard of that. Involved in movement, Parkinson's disease.
That's right. Its core job is action selection. It helps the whole team decide which specific action to take, and just as importantly, which actions not to take.
That not to take part seems really important in moral injury. If that initial shock from the supramammillary nucleus makes you want to just lash out or run away,
the BG has to step in. It acts like a gatekeeper, gonna-go system.
Huh.
It's heavily influenced by dopamine, the motivation chemical.
So it takes the ACC's ethical plan and makes it physical.
Yes. It inhibits the unwanted impulses like yelling and facilitates the chosen constructive action like taking a deep breath or speaking calmly. If you decide internally, I should step away and cool down, the BG is what makes your legs actually move you away.
It bridges knowing and doing.
It really does. It turns the I should into the I am doing.
So if the BG, the movement manager, isn't working well, maybe not enough dopamine, someone might feel stuck or act impulsively even if the planner, the ACC, knows better.
That's often where the breakdown happens, yes.
Yeah.
That gap between knowing the right thing and actually doing it can often be traced back to issues within the basal ganglia circuits.
Okay, and while all this internal debate and action selection is happening, the system still needs to be aware of the outside world, right?
Absolutely. You can't just retreat inside. You need vigilance. That's the job of the superior colliculus, or SC, the lookout.
The lookout. Keep in watch.
The SC is constantly scanning for shifts in the environment. Potential danger, something unexpected, maybe something exciting.
It's fast.
Incredibly fast, often faster than your conscious brain. It works on a preconscious level, helping you orient yourself, shifting your gaze towards something important before you've even fully processed what it is.
So in a moral crisis, while you're feeling all that internal turmoil...
Yeah, the SC makes sure you don't get completely lost in it. It keeps you aware of your surroundings. It prevents that tunnel vision you can get under extreme stress.
Yeah.
If the situation is actually dangerous, the SC is the part that subtly directs your eyes to the exit, maybe even before the fear fully hits.
Keeping you grounded and alert. Okay, so lookout keeps watch, movement manager acts, memory matcher gives context, planner coordinates. But who makes the final call on right and wrong? The judge. The conscience.
Ah, the ultimate ethical regulator. That heavy responsibility lands primarily on the orbitofrontal cortex, the OFC, our decision detective.
The decision detective, I like that. Why is the OFC so critical for moral decisions?
Because its main job is calculating value and predicting outcomes, especially social and emotional outcomes.
Okay, calculating value. How does that work for ethics? That sounds almost cold.
It sounds calculating, but it's essential. The OFC weighs the potential good versus bad of different choices by assigning a future value to them. It's asking, if I do this, how will I feel later? How will my friends or community react? Does this fit with who I believe I am?
So it's thinking about the long-term consequences, emotionally and socially.
Exactly. It's the part that simulates the future impact of your actions right now. In the Lego analogy, the OFC is the friend looking at the build and saying, yeah, that colorful piece looks great there now, but if we use it, the whole tower is going to be unstable later.
That makes sense. But wait, isn't the OFC also the part that gets talked about with, like, gambling problems, risky behavior, impulsive decisions? How can it be both the ethical detective and involved in risky stuff?
That is a fantastic question, and it really gets to the core of the OFC's complexity. It's not inherently good or bad. It's the value calculator.
Okay.
When it's functioning well, it accurately calculates the very high negative value of things like social rejection, guilt, or damaging your reputation. That calculation leads to ethical choices.
To avoid those negative future feelings.
Right. But if the OFC is dysregulated, maybe there's damage or a chemical imbalance like problems with serotonin. It might fail to properly weigh those future negative consequences.
So in gambling,
The huge immediate positive value of a potential win might overshadow the calculation of the likely long-term negative value of losing money. The calculator is biased.
and in moral injury, how might a dysregulated OFC play out?
It could go either way. Maybe extreme ethical paralysis, the person overcalculates every possible negative outcome and can't act. Or the opposite of kind of callousness, where the negative social and emotional costs are just ignored. The detective needs balance to make good judgments.
So the OFC's real job is ensuring we pick the path that preserves our long-term ethical self, even if it means some short-term discomfort or pain. That seems absolutely crucial when the whole system is reeling from moral injury.
It's the final check, the moral compass guiding the team.
Okay, let's bring it all back to that core problem, moral injury. That deep violation of your own values, maybe doing something, failing to stop something, or being betrayed. That awful mix of guilt, shame, anger.
And remembering, it's distinct from PTSD's focus on fear. Moral injury is about the wound to the self, to the ethical core.
So the moment that violation hits, this whole team, this functional cohort we've been describing, doesn't just shut down, it fights back, right? It tries to recover, to maintain integrity.
Exactly. It's a highly coordinated recovery effort. Let's walk through how the team responds step by step.
Okay. That horrible thought hits. I failed. Or I was betrayed. What happens first?
Well, that immediate, sharp, sickening jolt that's likely the supramammillary nucleus, the surprise sensor, firing hard, that's the initial shock wave.
The jump scare, emotionally.
Yes. But crucially, the supramammillary nucleus doesn't just fire and forget. It then starts working to regulate that startle. It tries to calm down the purely physiological panic, helping shift the feeling from raw terror towards something more like manageable distress.
Okay, so the shock happens, then starts to get managed. What's the planner doing? The ACC?
The ACC jumps in immediately. Remember, its job is conflict monitoring. And this moral injury is about the biggest conflict imaginable, your actions or experiences versus your deepest beliefs.
The alarm bell is ringing off the hook.
Loudly. So the ACC flags this huge discrepancy and starts searching for a way to resolve the emotional pain. Pushes you to externalize it, to try and talk about it, to put the feelings into words, maybe seek help or try to repair things with others. It forces the internal hurt into the conscious planning process.
Making you confront it, basically.
Yes. And as the ACC is trying to plan a way forward, the AVTC, the memory matcher, starts feeding it crucial context.
What kind of memories? Just replaying the bad event.
Hopefully not just that. Ideally, it pulls up memories of past resilience, times you overcame challenges, memories of past successes, reminders of your core identity before the injury. It provides anchors.
So it stops you from defining yourself only by this one awful event.
Exactly. It reminds the system, you've been through tough times before. You learn things, you have strengths. It contextualizes the pain.
Okay, so context is there. A plan is forming now for action. The basal ganglia, the movement manager.
Right. The BG gets the plan from the ACC. Let's say the initial urge, fueled by the shock and pain, is to withdraw completely or maybe lash out aggressively.
Destructive impulses.
Yes. The BG, guided by the ACC's more constructive plan, which is informed by the AVTC's memories, actively puts the brakes on those destructive pathways. It inhibits them.
The no-go signal.
The no-go on lashing out. And instead, it facilitates the go signal for a more measured response. Maybe it's pausing, taking that breath. Maybe it's formulating careful words. Maybe it's the physical act of reaching out for support. The BG makes the body follow the ethical intention.
While all this internal work is happening, what about the lookout, the superior colliculus?
The SC keeps you situationally aware. When you're in deep emotional pain, it's easy to get that tunnel vision, to disconnect from your surroundings. The SC works against that.
Keeping your eyes open, literally and figuratively.
Yes. It helps you stay grounded, aware of who's around you. Are they supportive? Are they part of the problem? It maintains alertness without letting the panic take over completely.
Okay, so the whole team is working. Managing shock, planning repair, using memory, controlling action, staying alert. What's the final piece?
The detective.
The OFC, the decision detective, provides that crucial final check and synthesis. It takes the emotional input, the memories, the planned action, and it evaluates the ethical dimension.
Deciding what's fair, what needs to happen for repair. Exactly. Is atonement needed? Is accountability required from others? The OFC weighs the options, considering the long-term social and emotional consequences, and prioritizes the actions that move towards restoring that feeling of ethical integrity. It ensures the final plan is, well, morally sound as best as possible under the circumstances.
So the whole team working together is basically the brain's mechanism for trying to heal from moral injury.
It is. Moral injury can feel incredibly isolating, but neurologically, the brain is deploying this whole coordinated team to process it, contextualize it, and guide constructive action. The goal is to bring the self, guided by that detective, back towards a sense of wholeness.
And that really explains why things like therapy, talking it through, getting external perspective, learning to pause before reacting, why those things actually work.
They absolutely do. Those are essentially behavioral ways to manually strengthen the connections within this functional cohort. You're training the ACC to communicate better with the OFC. You're helping the BG execute better choices. You're giving the AVTC more positive memories to draw on.
You're helping the Lego team build better together.
Precisely.
Okay, we've talked about the structure, the function, the team working together. Now let's shift gears a bit and go deeper, down to the building blocks. We need to talk about the molecular level, the stuff happening inside those brain regions.
Right. We're moving from the architecture to the blueprints, you could say. This is where we enter the omics era.
The omics era. Sounds powerful.
It is. So we've used the Lego Friends analogy, the ACC planner, the OSC detective, and so on. Now imagine each of those Lego friends is wearing a tiny incredibly complex superhero cape.
Okay, a superhero cape.
Woven from their unique biological code, their genes, the proteins they make, the chemicals they use to talk to each other, the omics era gives scientists the tools to read the patterns on those capes with incredible detail.
Reading the secret codes, like we mentioned earlier.
Exactly. Molecular precision. And the main tool driving this is something called massively parallel sequencing, or MPS.
MPS.
Right now.
What does that actually do?
Think of it like this. Instead of reading one Lego instruction booklet page by page, MPS lets you read thousands, even millions of instructions all at the same time. It's super fast, high-volume reading of biological code, like DNA or RNA.
So for the ACC, our planner, MPS could read its specific genetic instruction manual, see how well it's designed to be built.
Essentially, yes. We can look at the genomics, the person's inherited genetic code.
Yeah.
Are there variations in genes related to, say, stress hormone receptors in the ACC? Or maybe genes involved in making or breaking down neurotransmitters like serotonin or dopamine, which the whole cohort relies on.
Like that MAOA gene you sometimes hear about.
That's a classic example, yeah.
Mhm.
Variations there affect how key chemicals are processed. Someone might have a genetic variation that means their OFC, the detective, tends to run on a chemically bumpier road, making it potentially harder to make calm, ethical calculations under extreme stress.
So genetics might create a vulnerability, a predisposition.
It can create a tendency, yes. But, and this is crucial, it's not destiny. Genomics tells us about the potential, the blueprint, but we also need to know what's happening right now.
Okay, so what tells us that?
That's where proteomics and metabolomics come in.
Yeah.
Proteomics looks at all the proteins actually being made from those gene instructions, the workers on the site. Is the ACC actually building enough receptors to properly register those pain and reward signals we talked about? And metabolomics measures the small molecules, the chemical fuel, and exhaust fumes of the cells. When someone's experiencing moral injury, what does their stress hormone profile look like? Are the chemical pathways needed for neural repair working properly, or are they shut down?
Wow, so you can see the blueprint, genes, the workers, proteins, and the fuel and waste metabolites. That's an incredibly detailed picture.
It is. It moves us beyond just observing behavior or relying solely on talk therapy.
How does this change how we might help someone with moral injury, which, as we know, can be really difficult to treat?
It allows for truly personalized interventions. Imagine the omics data shows someone's hemifusum connections, the fiber optic cables, are structurally fine, but their whole system basically runs out of key neurotransmitters really quickly under stress.
So the wiring is okay, but the power keeps flickering.
Good analogy. In that case, the best approach might not just be cognitive therapy, but maybe also nutritional support or targeted medication aimed at boosting those specific chemical pathways. You're addressing the weak link at its molecular root.
Okay, let's bring this back to the functional cohort, maybe for a parent listening. If they see their child consistently struggling with making amends after mistakes or having really extreme, long-lasting reactions to perceived failures, how does this omics view help?
Well, first, it validates the struggle. It shows this isn't just, bad behavior or a lack of character. It's potentially a reflection of an underlying biological vulnerability in how their brain team handles stress.
That framing alone could be huge for a parent.
Huge. And if, hypothetically, data showed that child's ACC rapidly depletes serotonin under stress, the parent understands. Okay, their planner literally runs out of juice faster than average. That demands a different strategy.
Not just try harder, but maybe let's figure out how to manage your resources better.
Exactly. Proactive strategies. Maybe teaching coping skills before the stress hits. Maybe dietary changes known to support serotonin. Maybe just providing more co-regulation during stressful times. It becomes targeted.
So the big computer's reading the thousands of Lego instructions. Genes, proteins, chemicals help pinpoint which friend in the brain team needs the most support. Maybe the movement manager needs dopamine help, or the planner needs support handling stress hormones.
That's the goal, moving beyond one-size-fits-all to personalized optimization, building a stronger, more resilient cohort by understanding and addressing its specific molecular needs. We're learning that the deep pain of ethical injury is literally written in our chemistry.
It really emphasizes that each part of the brain team, each friend, has its own unique needs and strengths. And seeing signs of struggle after a shock or a deep hurt, that's seeing a system under real physical molecular strain.
Yes, and crucially, this strain isn't some unknowable mystery anymore. Even without fancy sequencing, the framework is valuable for parents, for everyone.
What's the core takeaway then, practically?
That active intervention works because it physically changes the brain. When you encourage talking about feelings, you are strengthening the ACC's ability to process conflict. When you promote teamwork and problem solving, you're improving the communication pathways, like the hemifusum. When you teach kids and ourselves to pause and reflect, you're engaging and strengthening the OFC, the detective.
You're helping write a better instruction manual for the next time the Lego team faces a challenge.
You really are. Piece by piece. Hashtag outro.
Well, that was definitely a deep dive. We went from Lego friends to molecular sequencing, all trying to understand how we handle that profound internal conflict of moral injury.
We really covered the whole functional cohort. The ACC, our planner, trying to make sense of it all.
Instantly getting that jolt from the supramammillary nucleus, the surprise sensor,
And getting context from the AVTC, the memory matcher,
acting through the BG, the movement manager.
while the SC, the lookout, keeps watch.
And the whole process is guided by the ethical judgments of the OFC, the decision detective.
And now, with omics tools like massively parallel sequencing, we can actually peek under the hood, read those molecular codes.
Which opens the door to much more personalized ways to help people heal and build resilience.
Absolutely. And the big insight, I think, the one that applies to everyone, not just in a clinic, is that building a more ethical, resilient self is about strengthening these connections. It's an active process.
Every time you catch yourself, pause, reflect, try to understand your feelings or someone else is after something tough, you're doing brain-building work.
You are literally strengthening those pathways. Every effort to engage your inner detective when you feel that shock of moral pain is a physical step towards a more integrated, stronger neural team.
So the final thought for you listening, as you go about your day, maybe pay attention to those small moments. Notice when surprise or hurt tries to hijack your plan. See if you can consciously bring your decision detective online. You might just feel that internal cohort working together, building something stronger, Lego piece by Lego piece.